graph where it potentially has an absolute maximum, we'd have to test 0, we'd have to test 30, we'd have to test 55. Okay? And we do displacement of those numbers. And obviously the answer should be at 30. Okay? I'm going to skip to number 9. I'd ask you tomorrow the conditions that have to be met for intermediate value theorem. It has to be continuous over the interval. I don't care if it's open or closed. It has to be continuous over the interval. I'm not going to worry about open or closed. And then also what it says, if it's continuous over the interval from, in this case, A to B, there exists at least one place in between A and B such that f of C is in between f of A and f of B. F of C has to be in between A and B at least one time. At least one time. That's all it says. Rolle's theorem. When we're looking at Rolle's theorem, you have to have three conditions. Three conditions for Rolle's. F has to be continuous over the interval, has to be differentiable over the interval, and f of A has to equal f of B at some point in time in that interval. Okay? If all three of those conditions are true, there exists at least one point where the slope of the graph is equal to 0, or it has a horizontal tangent. So, continuous, differentiable, f of A equals f of B. That tells you, Rolle's theorem tells you that the slope of the f prime of some variable C has to equal 0 at some point in time. And I can go through more of this later. Mean value theorem. Mean value theorem has to have two conditions that are true. It has to be sorry, let me start over. I'm trying to go fast so you guys have time. So let me slow myself down here. For mean value theorem, you have to have, the graph has to be continuous over the interval from A to B, and it has to be differentiable over the interval from A to B. If that's true, there exists at least one, there could be more than one, but at least one place where the slope of the secant line, which is the red line, is equal to the slope of the tangent line, which is kind of that ugly green. Okay? Number 12, I would ask you to repeat how to find this derivative of the limits. So I'm just going to talk generally about it, and then I'm going to tell you what I'm looking for. We want to get h to get to 0. That's why h is approaching 0. So we're making this h smaller and smaller and smaller and smaller, which is making this secant line smaller and smaller and smaller and smaller until it becomes a tangent line. That's what it's doing with derivatives. But the formula is, and it's just the change in y's over the change in x's. So it's the limit as h approaches 0 of f of x plus h minus f of x all over the change in x's. X plus h minus x, which is just h. So it's all over just h. So it's the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? Number 13. Product rule is when you take a product of two functions, multiply them, you're multiplying two functions, and you just take the derivative. Easy. That's it. There's nothing special about it, but you should be able to write it also. And the product rule of f of g, the derivative of that is f prime times start all over. The derivative of f times g is equal to f times g prime plus g times f prime. Quotient rule, when we had division of two functions, and you want to take the derivative of it, you use the quotient rule. So f over g, the derivative is g times f prime minus f times g prime all over g squared. It's that easy. Chain rule is when we want to take the derivative of a compositive function, f of g of x. F of g of x is a compositive function. So the derivative of f of g of x is f prime. We take f prime and we put g into it. So f prime of g of x times the derivative of g. So f prime, so put g into f prime and multiply by g prime of x. You can look this up. We know the cosine of 0 is 1. This is square root of 3 over 2. This is square root of 2. This is 1/2. And this just goes exactly backwards. So this is 0, 1/2 square root of 2 over 2, square root of 2 over 2 for both of these. And then this is square root of 3 over 2. Tangent starts at 0, then it's kind of ugly, square root of 3, then it's 1, then it's square root of 3 over 3, and then undefined. I think I skipped these. Cosine is 0, sine is 1, that is undefined. So you can look those up. You know, those are on your cheat sheet. Your graphs are on your cheat sheet. Displacement. Displacement is the accumulation of area. And it can be negative. Displacement can be negative. So it's the integral from A to B of v of t dt. Or the integral from A to B of velocity dt. Okay? Total distance is just like displacement, except where we do the absolute value of velocity, or absolute value of v of t. And it's the net area. You take any negative area and make it positive. So it's the absolute value of all of your areas. Okay? We already answered 20. Velocity and displacement. Velocity, total distance is the absolute value of displacement, integral of that. Given an initial condition, I would just ask you I would want to know what the position function is. Position is equal to f of a plus the integral from a to b of v of t dt, or you could write it as f of b equals f of a plus the integral from a to b of f prime of t dt. So we have to add the initial conditional. The initial conditional is f of a. All right. You might have a follow-up on some of these questions too. Speed is increasing when the acceleration and velocity have the same sign. Speed is decreasing. This occurs. So right here from the interval from 0 to 10, velocity is positive, acceleration is positive. So speed is increasing from this interval. Okay? Right here, speed is increasing here because velocity is negative and acceleration is negative. They both have the same sign. So these two locations, speed is increasing. I'm going to follow this because this was on your last test and we didn't talk about it. I might ask you this as a follow-up. Speed is a maximum. Speed is the absolute value of velocity. So speed would be a maximum from here to here because it has the highest absolute value of velocity. So speed is decreasing. Speed is decreasing where acceleration and velocity have the same signs. Sorry, take it back. Speed is decreasing. I said it right, but wrong problem. Speed is decreasing where acceleration and velocity have opposite signs. This occurs from here to here because velocity is negative and velocity is positive and acceleration is negative, and from here to here because velocity is negative and acceleration is positive. Just so you understand, acceleration right here is 0. Okay, acceleration right here is 0 too, but that's not that's why speed isn't going. Oh wow, is that it?
Yep.
Whew.